Hey guys, it's Miss Johnson, and I am here to bring you your notes for Unit 3 Notes 4, which is on dividing monomials. So far we've talked about adding, subtracting, and multiplying, and today we're going to look at dividing. Up at the top of your notes page for today, we're going to talk about the next rule, which is the quotient of powers. Quotient, of course, we know means division. So when I'm dividing powers, the rule tells me that I'm going to need to subtract the exponents. So subtracting exponents there. And then let's just take a look at an example here. If I expand this out, this example, I have a to the sixth on the top and a to the third on the bottom. That's a division of powers. They're the same base, a and a. So this is the same thing as saying a times a times a times a times a times a, 6 of them on the top, over a times a times a on the bottom. 3 of them on the bottom because it's a to the third power. Now, we all are familiar with this fact. Any number that we divide by itself is 1. 3 divided by 3 is 1. 6 divided by 6 is 1, whatever. So a divided by a also fits into that. A divided by a is 1, and these can go away. Here's another a divided by a, and here's another a divided by a. So after I simplify everything that I can, take a look at what's left. I have a times a times a on the top. I've gotten rid of everything on the bottom, and I'm left with a to the third power. Well, that's where we get into subtracting those exponents, because actually when I look at this, 6 minus 3 gives me 3, and that's where my third power comes from. So dividing powers means subtract the exponents. Let's just do a few basic examples. In number 1, I've got 4ab divided by a. So again, that principle that any number divided by itself is 1 means that these a's can cancel out. Well, after I cancel the a on the bottom, there's nothing left over in the denominator. I don't need a denominator anymore. I just look at what's left on the top. So I have 4b here, and that's my simplified expression. In number 2, I can cancel this x over x. And then when I look at the y's, that's the same thing as saying y times y times y, and over 1y on the bottom. One of them is going to go away. So that cancels out, leaving me with 2 left. And again, 3 minus 1 is the 2. So this ends up with being 6y squared. My x is canceled out. The y on the bottom canceled out. I was done with that denominator, so that's my simplified expression. When I get into number 3, now I've got some other numbers that I need to think about. I've got a 5x squared y on top and 10x on the bottom. So I need to make sure I simplify this fraction as well. Treat this 5 over 10 just as a fraction by itself. I mean, if I handed you the fraction 5/10 and said, what is that reduced, you would tell me that that's 1/2. You can divide out the common factor of 5. When I divide by 5 on the top, I get 1. When I divide by 5 on the bottom, I get 2. So that's where that 1/2 is going to come into play. This 5 on the top goes away. This 10 becomes a 2 on the bottom. Now the variables, I've got x squared over x. I can get rid of one of my x's. This x squared is like having 2 x's on the top. I've got 1 on the bottom. 1 can go away. So that one's going to go away, and instead of x squared, I'm going to have x to the first left over on the top. Y, that's just by itself. There's no y on the bottom, so I can't cancel it with anything. So now let's take a look at what we have left. The fraction that we have left is 1/2. So I have a 1 on top, I have x to the first power, and I have a y. On the bottom, I have a 2, and I have no more variables. Well, now this is a perfectly fine way to write this answer, but this is not how you would see it on a multiple choice test. We all know that multiplying by 1 doesn't change anything, and we also all know that taking something to the first power, we don't need to write that power of 1, so I actually don't need to write these. You would see this as x times y over 2. That's my simplified expression. Let's do one more kind of basic example. In number 4, I have 4a to the third b to the fifth over 14a to the fourth b to the second. Now, these are getting a little bit bigger. If it helps you, expand them all out. You could rewrite the top and the bottom expanded. I'd have 4a times a times a times b times b times b times b times b. There's no problem in doing that. It's okay to take a little extra time to really make sure that you see a clear picture of what's happening. So on the bottom, I have that 14. I have 4 A's, 1, 2, 3, 4 of them, and 2 B's, 1, 2. I always check before I start simplifying and get my next answer. Now you can cancel. So A over A goes away. A over A goes away. A over A goes away. I have an A left on the bottom. For the B's, B over B goes away. B over B goes away. I have 3 B's left on the top. For the fraction, 4 out of 14, these both can be divided by 2. We have a common factor of 2. So I can call this 2 and call this 7. So now let's put it all back together. I have a 2 on the top. I have b to the 3rd power. On the bottom, I have a 7, and I have an a to the 1st power. Now, if we take into consideration the rule that we just learned, one thing that I want to make clear of is, especially with these a's, take a look at your a's here. You have 3 on the top and 4 on the bottom. Now, we know that 4 minus 3 is going to give me 1, but you have to consider where the 4 is. Since there were more on the bottom, the leftovers are going to be on the bottom. Since I started with more on the bottom at first, whatever I have left, this 1 that I have left, is going to be left on the bottom. And you can see that in our answer from when we expanded it out too. The A is left over on the bottom, not up on the top. The B, 5 minus 2 is 3. I started with 5 on top, so now the extras are on top of my fraction. So be really careful about where those leftover A's and B's or X's and Y's are going to be. So let's just run through our checklist again, our simplified monomials. Our checklist that we talked about before, I think we talked about it with multiplying, but anyways, our properties of simplified monomials, we have 3 properties that we need to worry about here. The first one is each base appears exactly 1 time, and that's really important, especially for the variables. So each variable only once. You can write that down if that helps you. Variable only once. That's really what we're looking at for each base, is each variable. The other thing we need to consider is that there are no power of powers, or in other words, there are no parentheses left over. We should be all done with parentheses by the time we simplify it. And we also need to make sure that all of our fractions are in simplest form. And that's what we looked at with that example 3 and 4, where we had to reduce those fractions. Parentheses. Sorry, I didn't spell that right. Hello. So there we are. Okay. Let's just flip over to the back and talk about number 5, and we'll kind of see if we can put some of this into light a little bit more. So number 5, I have 5x to the 3rd, y to the 4th, over 15x squared y. So I need to take each piece that's in common. If I look at the fraction, I know that I can reduce 5/15 by 5. Both of them are divisible by 5. So if I divide 5 by 5, I'm left with 1. If I divide 15 by 5, I'm left with 3. Then I take a look at my x's. I have 3 x's on top, 2 on the bottom. Well, 3 minus 2 gives me 1. And then I need to ask myself, where did I start with more? I started with more up on the top. That means that's where that x is going to be left over. So I've got an x left over on the top. Those all go away. And then the y's, I have y to the 4th on top over y to the 1st on the bottom. 4 minus 1 gives me 3. And I started with more on the top, so I have y to the 3rd on the top. This y goes away. So now let's put it all back together. On the top, remember again, we don't need to write that coefficient of 1 because it doesn't really change our answer. So I've got x, y to the 3rd over 3. And that's my simplified expression. Each base is only there 1 time. I've got no parentheses. My fractions are reduced, and I'm set. All right, we're going to go ahead and stop your video for there at this point for today. Don't forget to hop back to Schoology and take the little quiz, and I will see you all tomorrow.